Hello everyone, welcome to my channel. In this video we are going to learn about dynamic memory management in the C language. So what is the dynamic memory management? So the memory is allocated dynamically at the runtime of the C program. So that is called as the dynamic memory management. So the process of allocating memory at runtime is known as dynamic memory management. So C provides certain built-in library functions like called memory management functions to allocate, reallocate and free the memory during the execution of the program. Okay, so C language provides certain inbuilt library functions, so that is a memory management function to allocate and deallocate the memory during the execution of the program. And we can find these memory management functions in the standard library.h header file. So if you wish to use the dynamic memory management functions in your program, then you have to include this header file in the program. So why do we need the dynamic memory management? So what is the importance of dynamic memory management? So we can go with the static memory management, right? So why we are going for the dynamic memory management? Okay, so when a C program is compiled, the compiler will allocate the memory to store different data elements, which is referred to as compile time or static memory allocation. Okay, so when a program is compiled, so the compiler will check for the errors in the program, and then if there is no errors, then it will allocate some memory for the program, where in the allocated area. Okay, the compiler will allocate the program variables. It will store the program variables in the some area which is already allocated for the program. Okay, so that is called as a compile time or static memory allocation. So there are certain limitations for the static memory management. That is, so this allocation is done in memory exclusively allocated to a program, and a static array has fixed size, and it is not efficient to create advanced data structures such as linked lists, trees and graphs. Okay, so here a compiler has to save the program only in the allocated area for the program. Okay, and the allocated area, that is the static array, is of a fixed size. If the number of variables in the program exceed, then we cannot allocate extra, it may get overflow. Okay, so the memory will be insufficient, and it is not efficient to create the data structures like linked list, trees and graphs. Okay, so now we will see how the C program is stored in the memory. Okay, so the memory allocation of a program associated with a C program. So this is how a C program will be stored in the memory. So with the local variables, global variables and instructions of the program and the static variables. So here the global variable, program instructions and static variable are stored in the permanent storage area, whereas the free memory, so this free memory is called a heap, and the local variables are stored in the stack area. Okay, so here the local variables are stored in stack area, and the global variables, program instructions and static variables are stored in the permanent storage area. So in between these two, so there is certain space, right? Free space is there. So that is called as a heap area. Okay, so the heap is managed by the operating system, and it is allocated to running programs. The heap is much larger than the program's local memory. It is used to hold programs data. So thus we can create much larger arrays and other data structures in the heap. The allocation on the heap is not a sequence. The memory blocks can be allocated anywhere. As a result, a heap memory is usually fragmented here. Okay, so here the size of the heap will keep on changing, because when the program is executed due to the creation and death of the variables that are local to functions and blocks. Okay, so here the size of the heap will be keep on changing. Okay, So while writing a program, we may create some new variables. Okay, so we will create the variables and we will destroy some variables. So that's why the heap will be keep on changing. Okay, and we have to make sure that the heap memory must be free, because otherwise the memory overflow may occur. So if you are go on creating and if you are allocating the memory in the heap dynamically, and if you are not destroying the memory that is allocated, then the free memory will be completely occupied and we will get an error called overflow error. Okay, and the system will get hanged. So to avoid this problem, so we have to allocate the memory and as well as deallocate the memory. Okay, so when it is used. So this is the importance of the heap. So here in the dynamic memory management, the variables, the space for the variables are allocated in the heap. Okay, dynamically. And after using that particular, after executing the program, that memory will be destroyed. Okay, so here the dynamic memory management will be so the variables the program will get stored in the heap. And the memory allocation functions mentioned here return a null pointer when they fail to locate enough memory requested by the user. Okay, so we have to create the space, and after using that free space in the heap, so we have to deallocate the memory. Otherwise when other program is requesting for the dynamic memory, then it may result in the null pointer. Okay, so when they fail to allocate enough memory requested by the user, it will return the null pointer. Otherwise it will allocate the memory for the user. So now let us see a real life situation related to the dynamic memory management. Okay, consider a program for processing the list of customers for a company. Okay, so in this program we are going to show the list. Now let us relate this dynamic memory management with a real life example. So here I am considering a program for processing the list of customers of a corporation. Okay, so here the list will grow when the names are added and it will shrink when the names are deleted from the list. Okay, so when the list grows, we need to allocate more memory space to the list. And similarly, when the customers leave the corporation, then the list will shrink. Okay, so here the dynamic memory management techniques permit us to allocate additional memory space or to release the unwanted space at the runtime. So this will be done using the dynamic memory management technique. So similarly here, this adding of memory and deleting of the memory is done using some library functions. Okay, so here in the dynamic memory management, we are having 4 library functions provided by the C. Okay, which is defined under the standard library.h header files. That is Mlog, CLog, and reallocation and free. So these are the 4 library functions provided by the user by the C program for the dynamic memory management technique: Mlog, CLog, reallocation, and free. So in the case of Mlog, so we can use this Mlog function for the structures, whereas CAllocation will be used for both the arrays and the structures. Okay, and reallocation. So reallocation means, so we are going to modify the already existing memory. So here some memory is allocated using the CLog or Mlog. So we are going to reallocate. That means we are going to increase the size of already allocated memory. And free. So using the free, we are going to delete the memory. Okay. So Mlog will allocate the single continuous block of memory. CLog, that is CLog will allocate multiple blocks of memory, and reallocation will reallocate the memory, already existing memory it will reallocate, and free means it is going to deallocate the memory. So now first we will see the Mlog. So if memory allocation is successful, they return a pointer to allocated block as a void pointer. Otherwise, they will return a null pointer. So we have already seen that in the dynamic memory management techniques, all the programs will run in the heap. So heap is a free space between the local variables and global variables, right? So all the programs will run in the heap. Okay, in the case of the dynamic memory management. So when the program execution is finished, so we have to deallocate the memory. Okay, so when the new program is started executing, so we have to allocate the memory. Okay, so in this manner we have to manage the heap. So if the memory allocation is full in the heap, then it will return a null pointer. That means it cannot allocate the memory because the heap memory is already full. It is filled with the many number of programs. Okay, and if the memory is free in the heap, it will allocate the memory for the program, for the user. So Mlog. The Mlog or memory allocation method in C is used to dynamically allocate a single large block of memory with the specified size. Okay, so memory here, Mlog stands for memory allocation. Okay, so it is used to allocate a single large block of memory with the specified size. It returns a pointer of type void. So this Mlog function returns a void type pointer. So we know that void type means it can handle any type of data type, right? So to store the data of integers, we need the int data type. Similarly, to store the decimal values, we need the float type. But so using the void pointer, we can store any type of data type. It doesn't initialize memory at the execution time, so that it has to initialize each block with the default garbage value initially. Okay, so it is not going to initialize the memory at execution time, so it will initialize the block with the default value, that is the garbage value. So the syntax of Mlog function is pointer equals to cast type pointer Mlog of byte size. So here in the byte size, so how many bytes of space we want, that we have to mention in the Mlog function, and the cast type is the void type, right? So we are going to typecast the size here, the memory, the size we are going to typecast here. Okay, so here the example for this Mlog function. So I am going to typecast the given size of integer. So int pointer Mlog of 100 into size of int. So what is the size of int here? 4 bytes. That is 4 into 100. That is 400 bytes of memory will be allocated using the Mlog function. Okay. So we are including the header files here: stdio.h, string.h, and standard library.h. So this one is for the dynamic memory management. So character memory allocation. So we are declaring a pointer here, that is a memory allocation of a character type. Okay, so here we are taking the pointer equals to Mlog of 20 into size of character. Okay, so here the return type of the Mlog function is a character pointer, right? So Mlog of 20 into size of the character. So here using the Mlog function, we are going to allocate 20 bytes of memory. So 20 into size of character is 1 byte. So 20 into 1 byte, that is 20 bytes of memory will be allocated here using the Mlog function. And if memory allocation equals to null, then it could not allocate the requested memory. And if the memory allocation is not equals to null, then the C compiler will provide the space it will provide the space here, right? So here it will perform the string copy of memory allocation virtual study time. Okay, so if the memory allocation equals to null, that means here the space in the heap is full. Okay, then it could not allocate the requested memory. And if the memory is available in the heap, then we are going to copy the virtual study time to the memory allocation character. Okay, and it will print dynamically allocated memory content is, so it will print the virtual study time on the screen. Okay, free the memory allocation. Okay, so in the dynamic memory management techniques, we have to free the memory. So we have created the memory of 20 bytes, and after copying the virtual time to the memory allocation, we are going to free the memory allocation. So after using this program, we have to free the memory allocation. So this is about the Mlog function. So next one is the CLOC is another memory allocation function that is normally used for requesting memory space at the runtime. So here we are going to store the derived types like arrays and structures. The CLOC or contiguous allocation method in C is used to dynamically allocate the specified number of blocks of memory of the specified type. Okay, so here we are going to create the multiple number of blocks of memory using the CLOC function. So CLOC or contiguous allocation function. So CLOC is used to allocate memory to mostly derived types like arrays and structures, and it is very much similar to the Mlog function with the 2 points here, which is different. So here using the CLOC function, so it will initialize each block with the default value 0, but whereas in the Mlog function it will initialize each block with the default value as garbage value. And here it has 2 parameters or arguments as compared to Mlog function. That is, in the case of the syntax of the CLOC function, so we are having 2 parameters here, right? That is n comma element size. But whereas in the case of Mlog function, we are having the only one parameter, that is the size of the particular size of the byte, right? Size of the type we are having. But here we are taking both the n comma element size. So pointer equals to cast type pointer CLOC n comma element size. So here the CLOCate function is going to return the void type pointer. So it is going to return the void type pointer. Okay. So after the element size is allocated here, so it is going to type convert it into the particular type mentioned in the CLOCate function. So here n is the number of elements and element size is the size of the element. So first of all, we will see how the CLOCate will be executed here in the program. So we are including the stdio.h, string.h and standard library.h. So in the main function, so we are declaring the memory allocation pointer here of a character type, and memory allocation equals to CLOC of 20 comma size of character. So we are taking the n comma element size. N is the number of bytes, that is 20 bytes, comma element size. So element is the of type for character. Okay, so 20 characters, that means 20 bytes of memory will be allocated here. So in the case of the Mlog function, it is going to provide going to provide contiguous memory allocation, but here CLOC will provide multiple blocks of elements. So it will provide multiple memory allocation blocks here. Okay, and it is going to initialize all the blocks to 0, and a pointer will be pointing to the first byte of the allocated region. Okay. So now, if memory allocation equals to null, then printf could not allocate the requested memory, because if the heap is full, it will result the null value and it cannot allocate the memory. Else, we are going to copy the virtual study time to the memory allocation pointer, and it will print the dynamically allocated memory content is virtual study time on the screen. So after that, free the memory which is allocated for the program. Okay, so in this way we are going to use the CLOC function. So now the next one is the reallocation. Okay, so the realloc or reallocation method in the C language is used to dynamically change the memory allocation of a previously allocated memory. So in the mloc and cloc functions, we are going to create certain block of memory, right? But here, after creating the block of memory, if you want to increase the size of the block or if you want to reduce the size of the block, then it will be done using the reallocation method. Okay, so using the reallocation function, we can change the previously allocated memory. If the memory previously allocated with the mloc or cloc is insufficient, realloc function can be used to dynamically allocate the memory. So it is going to reallocate. That means it is going to alter the size of the already existing block. So reallocation of memory maintains the already present value and new blocks will be initialized with the default garbage value. So here the initialization of the blocks will be with the garbage value. Okay. Syntax of the reallocation. Pointer equals to reallocate of a pointer comma new size. So this function allocates a new memory space of size new size to the pointer variable pointer and returns a pointer to the first byte of the new memory block. The new size may be larger or smaller than the already existing size. So remember, the new memory block may or may not begin at the same place as the old one. Okay. So here the new size that we are allocating here, it may or may not be available at the old one. Okay, it will be not available at the place of the old one. So here it may be we have to arrange the, so it is also possible that the memory allocated is larger or it may be smaller of the already existing memory. So now let us see an example here. So we are including the header files here, and in the main function, so we are declaring the memory allocation as a character pointer, and memory allocation equals to, that is a pointer equals to mloc of 20 into size of character. In the case of reallocation method, we have to first of all define the mloc, right? So after, so reallocate will work only on the already existing dynamic function, right? So mloc of 20 into size of character. That means it will allocate 20 bytes of 20 characters of length, 20 characters of memory. So if memory allocation equals to null, then it won't allocate the memory, and memory allocation is not equal to null, then it will copy the virtual study time to the memory allocation. Okay, and it will print the memory virtual study time on the screen. Okay, printf dynamically allocated memory content is virtual study time will be printed on the screen. And here I want to reallocate the memory here. So here already existing is 20 bytes of memory. So I want to reallocate the memory. So memory allocation. So I have to take the pointer name, that is memory allocation, comma 100 into size of the character. Okay. So what is the size of character? That is 1 byte. So 100 bytes will be allocated here. Okay. And memory allocation is having 20 bytes of characters. Here 100 bytes of characters are available. Is created here newly. Okay. So that means totally 120 characters of length will be provided here, right? So previously that is 20 bytes of memory available. Okay, and here after using the reallocation method, so we will be having 120 bytes of memory. That is 20 bytes is already existing and 100 bytes are of the newly created bytes. So 120 bytes of memory will be allocated for this program. So next, If memory allocation equals to null, then it won't allocate the memory. If the memory allocation not equals to null, then it will copy the space is extended up to 100 characters. So it will copy this string to the memory allocation, and it will print this string only on the output screen. This is the memory is, and it will print the space is extended up to 100 characters on the screen. Okay, so this is how the reallocation method will work. So after using the reallocation method, we have to free the heap memory. Okay, so next one is the free function. So the free function is used to deallocate the memory block allocated using one of the memory allocation functions like Mlog, Clog, and realloc. So using the free function, we are going to free the already allocated memory. That means we are going to deallocate the memory. So when the data in the particular memory block is no longer needed, so we need to free the memory. Okay, and if you are not deallocating the memory and you go on creating the memory, and you are go on creating the memory, right? If you are going to go on allocating the memory, then it is going to eat the space of the heap, and the heap will get completely filled, and we cannot run any program dynamically here. Okay, and the memory will get overflow, so the system will get hanged. So that's why, so after allocating, we have to deallocate the memory, which is no longer needed. Okay, so we have to deallocate the memory after the use of the memory space. Okay, the deallocation actually returns that memory block to the system heap. Okay, so it will return the memory block to the system heap, right? We know that. So we are going to run the programs the dynamic in the heap. Okay, so after creating, we have to destroy the memory, or else the heap will overflow. So the syntax of the free function is void free of void pointer block. Okay, so you are going to free the particular pointer here. So when a dynamically allocated block is no longer required in the program, we must return its memory to the system. Okay, suppose, so here if you are going to apply this syntax here, free of the particular pointer. Okay, so here this is a memory location, and a pointer is pointing to that particular memory location. So using the free function, we are not going to free this pointer. That means we are not going to remove this pointer. Instead, we are going to clear the memory space here. We are going to release the data in the memory block, right? We are going to free the data in the memory block, but not we are going to free the pointer. So here the syntax is like free of the void pointer block. But here we are not going to remove the pointer, but we are going to remove the data from the pointing location of the pointer. Okay, so this is about the free function, and so this is about all the dynamic memory allocation functions: Mlog, Clog, reallocation, free. Thanks for watching the video. Please do like, share, and subscribe to my channel. Thank you.